You know, your heart beats something like 100,000 times a day, every day, pushing life through your body. And you never even have to think about it. But have you ever stopped to wonder how that incredible machine was actually built? I mean, how does it go from just a simple biological blueprint to the powerful, complex pump sitting in your chest right now? Well, let's dive into that origin story.
We've all heard that phrase, right? Someone's born with a hole in their heart. It sounds pretty dramatic, and honestly, it can be. This one question is actually our doorway into a fascinating medical detective story. We're going to travel back in time to the first few weeks of life to figure out how the heart is put together and what happens when that assembly line makes a tiny mistake.
Because sometimes that mistake is way bigger than a small hole. Take this condition, for example, transposition of the great vessels. What that means is the plumbing is literally installed backwards. It's like a typo in the genetic code that creates two completely separate circuits that don't talk to each other. It's a single error that can be fatal if it isn't fixed, and fast. So how does our body build a perfect heart almost every single time, and what causes these critical, life-threatening flaws?
Okay, to understand how a flaw that big can even happen, we've got to go back to the very beginning. We have to become investigators, basically, and look at the original construction phase of the heart.
And the field we need to get into is called embryology. We're going to rewind the clock, go back to the very start, and watch this incredible construction project happen in real time. Because by studying how the heart forms, we can pinpoint the exact moments where things can go right or terribly wrong.
So, let's head to the construction site. In the first few days of development, the heart isn't a heart at all. It's just a couple of simple tubes. But then, this incredible process of folding and twisting and looping begins.
And the speed of this whole thing is just mind-blowing. At only 18 days post-conception, you've got these primitive blood vessels. By day 21, just 3 days later, they've already fused into one single tube. And then, just 2 days after that, on day 23, that tube starts this complex dance of looping and folding onto itself. It goes from a straight line to something you'd actually recognize as a heart in just a couple of weeks. By day 35, the basic 4-chamber structure is there. It's like biological origami happening at lightning speed. And here's the part that really gets me. Right in the middle of all this folding and shaping, during the 4th week of development, long before most people have any idea they're pregnant, that little heart starts to beat. The construction project is already up and running. It's unbelievable.
So now we've got a beating, looping tube. Awesome. But the next job is just as critical, building the walls. This process, which is called septation, is what divides that one big space into 4 specialized rooms. And this right here is where the mystery of the hole in the heart really begins.
Let's just focus on how the top 2 chambers, the atria, get divided. It's not as simple as building a single wall from top to bottom. It's this really elegant 3-step process. First, a thin little wall called the septum primum starts growing down. But before it closes all the way, a new hole opens up in it. This is super important for blood flow in the fetus. Then finally, a second, tougher wall grows next to the first one, and together they create this clever one-way door.
Here's a look at how that actually unfolds. You can see that first wall, the septum primum, growing down. Then the second wall, the septum secundum, forms right next to it. What they create is this special little tunnel with a one-way flap called the foramen ovale. This flap is genius. It lets blood flow from the right side to the left side before birth. But then, after the baby's first breath, the pressure changes in the heart and that flap gets slammed shut for good.
And that brings us right back to our original question. An atrial septal defect, the classic hole in the heart, is what happens when this intricate process doesn't finish perfectly. If those 2 walls don't seal up completely after birth, a hole is left behind. And just like that, by understanding the original blueprint, we've solved the first piece of our puzzle.
Okay, so building the rooms is one thing, but that's only half the battle. The next major challenge is the plumbing. See, early on, there's just one massive pipe leaving the heart. This has to be carefully divided into 2 major arteries, the aorta for the body and the pulmonary artery for the lungs. Now, the secret sauce here is a structure called the aorticopulmonary septum. It doesn't just grow down like a flat wall. It actually has to spiral as it divides the main pipe. This 180-degree twist is absolutely crucial. It's what makes sure the aorta gets connected to the left pumping chamber and the pulmonary artery to the right one. If that spiral doesn't happen, well, the consequences are catastrophic. And you can see the difference so clearly here. On the left, you have a normal heart. The plumbing crosses over, allowing deoxygenated blood to go to the lungs and get oxygen.
But on the right, that's what happens when the spiral fails. That's transposition of the great vessels. No twist. The aorta is hooked up to the right side and the pulmonary artery to the left. You end up with two closed loops. Blue blood just keeps going to the body, and red, oxygenated blood gets stuck going back and forth to the lungs. Without surgery, this just isn't compatible with life.
The precision of this blueprint is just wild, even when you look at the other big arteries. They all develop from these structures called pharyngeal arches. You can think of them as different raw materials that are pre-programmed to become specific pipes. For example, one arch is destined to become the main arch of the aorta. If there's an error in its instruction manual, you can get a dangerous narrowing. Another arch forms a temporary vessel that's supposed to close right after birth. If it doesn't, that's another specific defect. Every single line of code in this blueprint matters. So let's just take a step back. We've gone from a couple of simple tubes to a fully plumbed 4-chambered heart that's beating on its own. It's a journey of twisting, folding, and building that is just an incredible feat of biological architecture.
I mean, when you really stop and think about the sheer complexity of it all, it's just astonishing. This isn't just one of the greatest construction projects in biology. It's a flat-out miracle that it goes right almost every single time.
And this is why it all matters so much. This isn't just a cool science lesson. This deep, detailed knowledge of embryology, of the heart's original blueprint, is the absolute foundation of modern pediatric cardiology. Because surgeons understand exactly which step went wrong, they can now go in and repair these imperfections. They can patch the walls, they can replumb the arteries, and give these kids a shot at a healthy life. Just think about that for a second. This entire high-stakes construction project, this incredible molecular and cellular dance, was completely finished inside of you before you ever took your first breath. It really makes you wonder, right?